A state of emergency has been declared on the Greek island of Santorini after days of consecutive earthquakes. It comes after a magnitude 5.2 tremor was recorded at 21:09 local time, 19:09 GMT, on Wednesday between the Greek islands of Amorgos and Santorini, making it the strongest in recent days. It is estimated to have occurred at a depth of 5 kilometers, 3.1 miles. The decree will be in effect until the 3rd of March to address the emergency needs and manage the consequences, officials said. More than 11,000 people have already left Santorini, with around 7,000 departing by ferry and 4,000 by air. A 4.7 magnitude quake was also recorded southwest of Amorgos at 0750 local time on Thursday, following 57 tremors between midnight and 0630. Magnitude refers to the size of an earthquake, with increases marked as decimal points. A magnitude 6.0 and above is considered severe, whereas a magnitude 5.2, the strongest experienced so far in the region, is considered moderate. So far, no major damage has been reported on the island, but authorities are preparing in case a larger quake hits. Greek Prime Minister Kyriakos Mitsotakis is expected to visit Santorini on Friday. Vasilis Karastathis, director of the Geodynamic Institute, told Greek state-owned broadcaster ERT News that seismicity continues at the same pace as in previous days, intense. "We have a fairly high number of earthquakes with magnitudes above 4, he said. "We are still in the middle of the road. We have not seen any thinning, any sign that it is heading towards retreat." Santorini welcomes millions of tourists annually, but it is currently low season, meaning local residents and workers make up the majority of evacuees. Due to the state of emergency, repairs to things like public roads and ports can skip usual bureaucratic requirements and begin immediately. "We are in a particularly uncertain stage, where we cannot accurately determine the duration of the seismic swarm nor its exact origin," Kostas Sinolakis, a professor of natural disasters, told ERT News. He said it is necessary to remain prepared for the possibility of a larger earthquake and a volcanic crisis, like the one in Santorini. To cope with this, extra generators have arrived, and a backup telecommunications station is being set up at Santorini City Hall. Islanders also fear of a tsunami, with makeshift defenses built from sacks along Monolithos Beach in Santorini, where the buildings are very close to the sea. All hospital employees are on standby to help those who have remained on the island, with all leave and days off canceled. Additional ambulance crews, police officers, soldiers, and military vehicles have also arrived in Santorini, with medical personnel sent from Naxos, another island. Vasilis Kikilias, the Climate and Civil Protection Minister, said units of firefighters trained in natural disasters were being dispatched to Santorini. Teams with special dogs and a mobile operations center have also been sent to the island, while helicopters are on standby. Kikilias also said the Coast Guard and armed forces would be available to assist vulnerable people who wish to evacuate. Poor weather means the ferry from Santorini to Piraeus port near Athens is not operating. The adverse conditions are expected to continue over the coming days. Many travelers remain at Santorini's port to board emergency ferry routes that have been set up. Schools on Santorini and other neighboring islands, including Anafi, Paros, Naxos, and Mykonos, will remain closed until Friday, when authorities will make a decision about when they can reopen. Earlier on Wednesday, Greek Prime Minister Kyriakos Mitsotakis had struck an optimistic tone at a meeting of civil protection experts. "All plans have been implemented. Forces have been moved to Santorini and the other islands, so that we are ready for any eventuality," he said. He asked the islanders to stay calm and cooperate with the authorities. Santorini is on what is known as the Hellenic Volcanic Arc, a chain of islands created by volcanoes, but the last major eruption was in the 1950s. Greek authorities have said the recent tremors were related to tectonic plate movements, not volcanic activity. Scientists cannot predict the exact timing, size, or location of earthquakes. but there are areas of the world where they are more likely to occur, which helps governments prepare. Earthquakes are the result of movement of tectonic plates in the Earth's crust. Sometimes these plates lock together when they meet, which is called a plate boundary or a fault line. In the past 48 hours, the Greek island of Santorini has been thrust into chaos following an intense series of seismic events that have forced a mass exodus of its residents. Nearly 9,000 locals have been evacuated since Sunday, with emergency flights arranged to continue the process. Scientific measurements indicate that more than 2,000 tremors have rattled the region, and experts caution that such activity could persist for weeks. Amid these unsettling natural occurrences, authorities have taken precautionary measures, closing schools and advising the public to avoid large indoor gatherings. The island, renowned for its breathtaking beauty and popularity with tourists, now finds itself deserted of its usual inhabitants, especially since the off-peak season means that visitors are few and far between. Seismic readings from the Aegean Sea, northeast of Santorini, have recorded multiple tremors. A notable 5.3 magnitude earthquake struck early this morning near the Colombo volcano region, marking the most significant event in a sequence of heightened activity recorded within the past 5 hours. This quake contributed to a complex tapestry of seismic events over the previous 24 hours, as various stations captured a veritable cascade of tremors. The distribution of these earthquakes revealed clusters and a gradual migration toward the Santorini volcano, suggesting that volcanic processes might be playing a role alongside traditional tectonic forces. Although the volcanic alert for Santorini remains at level 2, scientists are maintaining a vigilant watch, considering the intricate interplay between tectonic plate movements and potential volcanic activity. The evolving situation demands continuous monitoring, as the subtle shifts in seismic patterns raise questions about the underlying mechanisms at work. Even as data pours in and the seismographs paint a picture of relentless Earth movements, the broader narrative of these natural events continues to unfold, underscoring the delicate balance between scientific observation and the unpredictable forces of nature. The most recent map displays the Colombo volcano highlighted in yellow, indicating that it is currently at stage 2. A sign of unrest. Similarly, the Santorini volcano, updated today, remains at a level 2 alert. Despite an ongoing swarm of earthquakes, there has been no new evidence of an eruption, although the potential for a sudden escalation remains ever present. Data from live seismic stations reveal that while smaller tremors continue to occur, there is a noticeable uptick in activity. A 4.9 magnitude event from yesterday stands out among recent quakes, and there is a clear trend of seismic energy migrating southward beneath the Santorini area over the past few days. Recent models, such as those from the EMC, show purple dots on the map representing earthquakes recorded in the last hour, including a 3.3 magnitude tremor noted approximately 22 minutes ago. Multiple seismograph stations are registering a high volume of activity. One station in particular displays an unusually cluttered seismograph, a stark departure from its typical calm line, underscoring the intensity of the current seismicity. The continuous rumble of the earth has left many inhabitants so unsettled that some have taken to sleeping in their cars, fearing structural collapse in their homes. Although there have been no reports of significant physical damage to the island, emergency protocols have been activated as a precautionary response. Early Tuesday morning, hundreds gathered at the port to board ferries destined for the mainland, while additional flights were organized by local airlines in coordination with the Ministry of Climate Crisis and Civil Protection. For those who have called Santorini home, a community of approximately 15,500, the departure is a profound disruption to everyday life. Longtime residents, including families who have lived on the island for generations, have chosen to leave temporarily, citing the unnerving sounds of the shifting earth as the most distressing aspect of the ordeal. Despite the absence of visible destruction, the psychological impact of the continuous tremors has been significant. Local leadership, including the mayor of Santorini, has maintained that the island is well prepared for prolonged seismic activity, urging the community to face the crisis with patience and calm. Emergency plans are in place, featuring designated shelters and provisions to support the population should the tremors escalate. In a coordinated effort, representatives from the government, armed forces, and emergency services convened to assess the situation, with further strategic meetings planned in the coming days. On Monday, Prime Minister Mitsotakis emphasized that the government was actively addressing a formidable geological event unfolding in the region. While seismologists have assessed the recent tremors as relatively minor, officials have already implemented precautionary measures, preparing for the possibility of a larger earthquake. Residents in areas such as Amudi, Armeni, and the old port of Fira have been advised to evacuate due to the threat of landslides, underscoring the seriousness of the situation. Emergency services have mobilized quickly, with the South Aegean Regional Fire Department on high alert and rescue teams positioned near conspicuous yellow medical tents. As scientists analyze a wealth of data stemming from hundreds of earthquakes shaking the Cyclades Islands, attention has focused on a small islet named Anidros, northeast of Santorini, from which much of the more pronounced seismic activity appears to emanate. The intensity of tremors is not confined to Santorini alone. Other islands like Anafi, Amorgos, and Ios are also under close observation. On Santorini, concerns are amplified by the unique challenges posed by its soil composition and building structures, which might not withstand a major quake. Despite being part of the Hellenic volcanic arc, a chain of islands formed by ancient volcanic activity, the recent events have been attributed to tectonic plate movements rather than any imminent volcanic threat. The last significant volcanic eruption on Santorini occurred in the 1950s, and current scientific consensus points to natural shifts along the plate boundaries. Now let's explore two compelling scenarios that might occur in the coming days. Throughout history, the Greek landscape has been repeatedly reshaped by titanic forces that serve as both a reminder of nature's fury and a testament to human resilience. The 365-80 Crete earthquake, estimated at a magnitude exceeding 8.0, remains one of the most cataclysmic events recorded in the ancient Mediterranean. Occurring on July 21st, the tremor is believed to have ruptured a major segment of the plate boundary near Crete, unleashing a tsunami of staggering proportions. Historical accounts describe entire coastal settlements being swept away in a matter of minutes as water inundated regions of Greece, Egypt, and Libya. The event not only decimated communities, but also left an indelible mark on the collective memory of civilizations, influencing art, literature, and even religious thought for centuries to come. Fast forward to the 20th century and the 1953 Ionian earthquake, measuring a solid 7.2 on the Richter scale, brought a modern reminder of the region's seismic volatility. Striking the Ionian Islands, particularly impacting Kefalonia, Zakynthos, and Ithaca on August 12th, this earthquake caused widespread destruction of buildings and infrastructure, leaving behind a trail of hardship and a long road to recovery. The devastation of 1953 spurred a re-evaluation of building practices and emergency preparedness in the region, lessons that continue to inform modern engineering and disaster response strategies. More recently, the 1999 Athens earthquake, though lower in magnitude at 6.0, struck at the heart of modern civilization on September 7th in a city renowned for its historical and cultural significance. This quake resulted in the tragic loss of over 140 lives and inflicted severe damage to the urban landscape. The tremor disrupted lives and livelihoods, transforming the bustling metropolis into a scene of chaos and uncertainty, while also triggering a nationwide introspection about urban resilience and the necessity for rigorous building codes in seismic zones. Interwoven with these seismic events is the awe-inspiring yet destructive history of Greece's volcanic activity. The eruption of Thera, modern-day Santorini, around 1600 BCE stands as one of the most powerful volcanic events in human history. This colossal eruption not only reshaped the island itself, but also unleash massive tsunamis and widespread ash fallout that is believed to have contributed to the decline of the Minoan civilization. The eruption's far-reaching impact, both in climatic and cultural terms, has been etched into the annals of history as a pivotal moment when nature's might irreversibly altered the course of human development in the region. Equally significant is the 1650 AD eruption of Colombo, a submarine volcano located near Santorini. Although occurring underwater, this explosive event proved deadly as the rapid release of toxic gases devastated nearby settlements, claiming the lives of approximately 70 people. The Colombo eruption serves as a stark illustration of how submarine volcanic activity, often hidden from immediate view, can nonetheless have catastrophic consequences for coastal communities. Looking toward the future, these historical events provide both a framework and a warning. In a likely scenario, moderate seismic activity and intermittent volcanic unrest may continue along the fault lines that delineate the convergence of the African and Eurasian plates. Swarms of quakes, ranging from magnitude 3 to 5, could persist in the Aegean, while the volcanic systems of Santorini and Colombo remain in a state of cautious alert, occasionally emitting minor ash clouds and gas releases that serve as reminders of the latent power below. In the worst-case scenario, however, the accumulated stress along these fault lines might suddenly release in a massive earthquake, a magnitude 6 or greater, that destabilizes the volcanic systems. Such an event could trigger a violent eruption from either Santorini or Colombo, unleashing torrents of ash, pyroclastic flows, and toxic gases that mirror the devastation of ancient times. The resulting tsunamis and widespread structural collapse would echo the calamities of 365 AD and 1650 AD, transforming the region into a landscape of profound loss and upheaval. In this scenario, the modern world would be forced to confront the ancient and unyielding forces that have repeatedly shaped the history of Greece. Is there a possibility that nearby volcanoes could erupt simultaneously? While it is theoretically possible for volcanoes in the same region to erupt simultaneously, such an event is considered highly unlikely due to the complex and independent nature of each volcanic system. In regions like the Aegean, where the powerful tectonic forces of the African and Eurasian plates continuously reshape the landscape, individual volcanoes such as Santorini and the submarine Colombo operate within their own unique magmatic systems. Each of these volcanoes has developed over millennia to maintain its own reservoir of magma, with distinct chemical compositions and intricate physical structures that govern how pressure builds and is eventually released. These differences mean that the specific conditions required for an eruption, ranging from the accumulation of volatiles to the melting point of the rock, and even the orientation of subterranean fractures, vary significantly from one volcano to the next. Scientific studies reinforce the notion that even though these volcanic systems share a common tectonic backdrop, the triggers that set an eruption in motion tend to be highly localized events. For instance, the process that might lead to an eruption at Santorini could involve a delicate interplay between rising magma and the weakening of overlying rock layers, while Colombo, submerged beneath the waves, might respond to entirely different pressure thresholds and chemical signals. Researchers have observed that factors such as the rate of magma ascent, changes in its viscosity, and the development of localized cracks in the Earth's crust contribute to these differences. In essence, each volcano responds to a unique set of circumstances, making the probability of two erupting at precisely the same moment extremely low. That said, nature is never entirely predictable. There exists the possibility that a significant tectonic event, such as a major earthquake, could dramatically alter the stress fields over a broad region. Such an event might disrupt the equilibrium within multiple volcanic systems simultaneously, nudging them closer to instability. This scenario, while remote, reminds us that the dynamic Earth does not always follow our expectations. The prospect of a regional earthquake acting as a catalyst for heightened volcanic activity underscores the interconnectedness of our planet's systems, where even distant events can send ripples through the geological fabric. Historical records and modern observations further illustrate that while eruptions in the region have occasionally occurred in close succession, true simultaneity, where two or more volcanoes erupt at exactly the same moment, remains exceedingly rare. The intricate interplay between regional tectonics and local volcanic conditions means that even if one volcano is showing signs of imminent eruption, it does not necessarily serve as a precursor or trigger for another. This inherent unpredictability and complexity lend an air of mystery and caution to the study of these natural wonders. A reminder that while we can understand the processes at work, nature still holds secrets that defy simple explanation. Seismic activity beyond Santorini. Seismic activity continues to be monitored with vigilance. Despite a temporary pause at the Raspberry Shake 4D station, the earlier 5.3 magnitude quake is seen as a potential indicator of escalating activity. In the world of seismology, predicting the precise timing, magnitude, or location of an earthquake remains elusive. However, understanding that such events are more likely to occur along fault lines helps authorities develop strategies to mitigate risk, whether through designing earthquake-resistant structures or evacuating vulnerable populations at the first signs of danger. The coordinated efforts of scientists and government officials aim to reduce potential damage and protect lives amid nature's unpredictable power. Beyond the immediate vicinity of Santorini, the surrounding region remains relatively quiet, aside from a few deep earthquakes detected north of the area, one near Italy and another further north of Turkey. Meanwhile, across the Atlantic Ocean, activity along a rift boundary is stirring, with a couple of magnitude 5 events reported down south, signaling that the global tectonic landscape is becoming increasingly active. In Japan, conditions remain relatively tranquil, with no significant disturbances detected along its plate boundaries. Meanwhile, a magnitude 5.9 event was recorded yesterday near the Indonesian islands, and today, a few additional tremors have emerged slightly further south in the same region. Along that same boundary, activity is minimal, although there is a small cluster of events near Alaska, including a 4.4 quake early this morning. The west coast of the United States shows similarly subdued activity. In the Seattle area, a minor 1.2 tremor was observed to the north, while Southern California experienced only modest quakes, none exceeding 2.5, except for a recent 2.9 event along the San Andreas Fault Zone. In Wyoming, a small quake was registered last night, and near Yellowstone, a 3.1 tremor indicates that low-level seismic activity continues. Seismograph records reveal a flurry of microquakes, most falling below a magnitude of 2.0, contributing to a complex yet relatively contained picture of the region's ongoing geological movements. Further east, across Ohio and the broader eastern United States, no new significant events have been reported since yesterday's activity, leaving the area notably quiet. As the seismographs display a chaotic mosaic of data, attention turns skyward to the realm of space weather. The sun's visible disk is dominated by a massive sunspot labeled 3981, which currently commands the scene. Magnetogram readings of the sunspot's central region reveal a tapestry of deep reds and cool blues, indicative of intricate magnetic dynamics. These signals suggest the possibility of an impending X-class flare, with the potential for additional bursts of solar activity. Yet, as observations indicate a gradual decay in the intensity of these phenomena, there remains